Have you ever been on a flight and looked out the window and just wondered, how does this all work? I mean, how do thousands of planes from all these different countries share the sky without a hitch? Well, the answer isn't in a cockpit or some flashy control tower. Turns out it's in an office building in a city you might not expect. So yeah, let's get into it. We're heading to Montreal, the unseen headquarters of global aviation.
Just think about this number for a second. Every single day, more than 100,000 commercial flights take off and land around the world. That's more than one flight every second. It's this incredible, massive ballet of logistics and engineering. So, what's stopping all of this from turning into total chaos?
Exactly. Who writes the rule book? How does a pilot from Japan know the exact same landing procedure as a pilot in Brazil? How can an air traffic controller in Egypt speak a safety language that a crew from Sweden instantly understands? There has to be one single global standard. The question is, who sets it?
And there it is. Believe it or not, the quiet, diplomatic nerve center for the entire world's civil aviation system is located in Montreal, Canada. This one city is where the fundamental rules of flying get hammered out, written down, and agreed upon by pretty much every nation on Earth.
Okay, so let's pull back the curtain and meet the organization running the show. It's called the International Civil Aviation Organization, or ICAO for short. You can think of them as the global air boss, the ones responsible for making sure your flight is safe and orderly no matter where you are in the world. So what is ICAO really? Well, it's a specialized agency of the United Nations. It was born out of a huge international agreement called the Chicago Convention all the way back in 1944. And its whole job from day one has been to act as this global forum where countries can agree on all the standards and practices that keep air travel running smoothly and safely.
And you can really see how we got here on this timeline. The idea of a unified sky isn't new at all. It actually started with an earlier group called ICAN way back in 1919. But the real game changer was in 1944. That's when 52 nations got together, signed the Chicago Convention, and laid the groundwork for the modern system. After a couple of years in a provisional state, ICAO officially became a permanent thing in 1947, setting up its home base in Montreal.
Of course, it's not always smooth sailing. Because ICAO is the UN body, it sometimes gets caught in the middle of some pretty tricky diplomatic situations. Back in 2020, for instance, there was criticism when the organization blocked social media discussions about Taiwan's exclusion from safety bulletins. And it also has to deal with ongoing technical and political headaches, like worries over GPS signal interference near the Korean peninsula, where it has to urge North Korea to prevent anything that might endanger aircraft.
All right, so beyond all the high-level diplomacy, ICAO's work actually has a direct impact on your travel, often in ways you would never even think about. So let's break down how these standards literally shape your journey from check-in to landing.
Get a load of this. Ever wonder if just any old plane can land at any airport? The answer is a hard no. ICAO created something called the Aerodrome Reference Code. It's a really simple system that classifies runways based on the size of the aircraft they can safely handle. So, a code F runway, for example, has to be wide enough and strong enough for a monster like an Airbus A380. This simple code means a pilot anywhere in the world knows for sure if a runway is safe for their plane.
And how about this one? The passport in your bag. The whole reason you can just scan it at an electronic gate in almost any international airport is all thanks to ICAO's Document 9303. They're the ones who standardize that machine-readable zone at the bottom, and later, the biometric chip inside. It's a global standard that makes your trip through border control way faster and more secure.
Okay, this is where it gets kind of wild. Even though ICAO pushes for standards, it also has to manage this weird hybrid system of measurements. So the global standard for speed is knots, and for altitude, it's feet. But if you're flying in China or North Korea, you suddenly have to switch to meters for altitude. And while most of the world uses meters for runways, North America sticks with feet. ICAO's framework is what makes this potential mess work.
So it's pretty clear ICAO has built this incredibly successful system for global aviation. But now, that very system is staring down its biggest challenge yet, climate change.
I mean, just pause and think about that achievement for a moment. For over 3/4 of a century, this organization based in Montreal has been the absolute bedrock of aviation safety, uniting the entire planet under one set of rules for the sky. It's remarkable.
And that brings us to the big question. Can an organization that was designed in the 20th century to handle safety and logistics pivot to solve the defining crisis of the 21st century? The need to decarbonize is changing the entire game.
So, how do you solve a 21st century crisis? Well, you need 21st century tools.
And that brings us to a concept that is truly revolutionary, the digital twin. This isn't just some small upgrade. It's a completely new way of thinking about how we can build and fly planes sustainably.
So what in the world is a digital twin? Okay, imagine creating a perfect virtual copy of a specific jet engine or even a whole airplane. But it's not just a 3D model. This digital copy is constantly fed real-time data from the actual physical engine out in the world. It basically lives, ages, and gets stressed just like the real thing. This lets us predict failures before they happen and find ways to optimize efficiency like never before.
And when it comes to sustainability, this is where it gets really powerful. Digital twins can drive green innovation across a plane's entire life. It starts right at the beginning, helping design more efficient engines. It helps certify new, sustainable materials. While the plane is flying, it can optimize flight paths to save fuel. And it goes all the way to the very end of a plane's life, helping us figure out the best way to recycle it. It's the whole shebang.
And look, this is not just theory. The impact is real. One study has already shown that using a digital twin just for predictive maintenance on jet engines can cut downtime by up to 30%. And less downtime means more efficient airlines and a longer life for these incredibly resource-intensive parts.
What we're really seeing here is the start of the next great transformation in aviation. For decades, the rules of flight were written in convention halls in Montreal. Now, it looks like they're also going to be written in code.
This quote from some recent research really just nails it. It says that digital twins are not just tools to make things perform better, but are, quote, strategic infrastructures capable of embedding environmental intelligence across the aviation lifecycle. In other words, they're not just a tool, they're a whole new foundation.
So, I'll leave you with this final thought. For 75 years, we've built the safest transportation system in history on global agreements and paper conventions. As aviation now faces this urgent climate crisis, will the future of flight depend more on algorithms than on handshakes? It's a question that is going to completely redefine our skies.